Starlink 626 launch coverage. But don't worry. Yeah, we'll be back here. Well, we'll just pick up the coverage and then we'll go from there. We'll see what's good. Do you even go to the moon? Yeah. Yeah, we did. Hey, Tech. I'm great, man. How are you? Gotta give my damn processor and graphics card a break here for a second. Alright. There we are. So this is Space Launch Complex 40 down at Cape Canaveral. We watched the Starlink 625 mission launch off this thing less than a week ago. First stage there is booster serial number 1058, 18th flight for this booster. This is a Starlink mission launching 23 Starlink V2 satellites. Starlink is SpaceX's internet satellite constellation. Look at the crew access tower. SpaceX has been slowly upgrading this pad to be able to get people onto their Dragon capsule, their crew capsule, to get up into space. That's what this tower is right here. That's the other reason why I wanted to see it. I wanted to check on that tower construction. It's crazy. They work on the tower during the day and then launch at night, which is just weird. This launch pad, Slick 40 has seen more launches in the past 5 years than the past probably 60 prior, which is crazy. But it is cool to see all these rockets. It's cool to see them fly. It's awesome.
Stage 2, blackfoot complete.
Okay, ground gas closeout here should happen in a moment. You should see a big vape cloud come out of the top here. You know what the most used pad is? 39A, I would guess. Right? 39A is like 140, 150 launches from it at least. I mean, maybe probably even more. So, ground gas closeout. There's the vape. What they're doing is the fuel lines for the second stage, right, is up here. The second stage is basically a part that breaks off from the vehicle, right? And this is the part up here from there up that gets you up into space. The payload's inside of this aerodynamic shell. The fuel lines, the fuel and oxidizer lines for that second stage are going up the side of the erector. Yeah, I know. And what they did was they just evac'd all of the liquid oxidizer out here. They're using a cold oxidizer in the form of liquid oxygen. It's a cryogenic propellant. That's a real cool sciencey way of saying it's really freaking cold. So
you go for launch.
Ice builds up on the sides of the vehicle because it gets so cold it condenses the atmosphere around it. So we should be at T-minus 30 seconds.
T-minus 30 seconds.
Yeah, I just said that, guy. All right. At T-minus 10, we should see the sound suppression systems turn on. That's basically a water fountain that shoots at the bottom of the pad here.
15 seconds.
All right, here we go.
T-minus 10, 9, 8, 7, 6.
Sound suppressor is
5,
on.
4, 3, 2,
engine ignition.
1, ignition, and liftoff. Go Falcon, go Starlink.
Starlink 626 is in the air. 18th flight for the first stage. Moving 23 Starlink satellites.
The vehicle is pitching downrange
to low Earth orbit. Okay.
M1D propulsion is nominal.
Okay, booster guy says that propulsion is good. Next step here is power. The call for power and telemetry at T plus 45 seconds. Vehicle's now 2.4 kilometers in altitude, traveling at 650 kilometers an hour.
Power and telemetry is nominal.
Good call on the power and telemetry here. Why is it rotating? It's turning to get into the right orbital tilt, Farouks. So it's called a flight azimuth. The flight azimuth indicates the tilt of the orbit.
Is supersonic.
The flight azimuth indicates the direction to get into the right tilt for the orbit around Earth. So we measure like orbit tilt, or
Max Q.
there's the call for max Q. We measure that by with a variable called inclination. Inclination is how tilted your orbit is relative to the equator. It's turning so it can follow the right path to get into the right tilted orbit that the satellites need to be in to get good communications.
And that chill has started.
In this case, that's a 54-degree inclined orbit. So Starlink satellites are tilted relative to the equator. We've gone through maximum dynamic pressure, that's peak aerodynamic load, and Merlin 1D vacuum chilling has begun. This is basically when they flow propellants into the second stage engine to make sure it's at the right operating temperature. Remember, they're using cold propellants, so if you flash freeze the engine, it likes to explode. That's not good. So you want to trickle the propellants in to prime it and make sure it's at the right operating temperature. Vehicle's now 42 kilometers in altitude, traveling at 5,500 kilometers an hour. Yeah, 23 satellites. That's 18,400 kilograms of payload. Okay, we should see main engine cut off right around 2.5 minutes here.
Miko.
There's staging.
Stage separation confirmed.
Okay, good separation. Upper stage ignition.
MVAC ignition.
Ignition is good. Stiffening separation is good. We got a good separation. 18th flight for that booster. Look at how cruddy it looks on the inside there. See that? Okay, grid fins are deploying here on the first stage. The first stage is not finished yet. It's going to try and land so SpaceX can reuse it maybe for a 19th time in the future.
Both vehicles are following nominal trajectories.
You got a good trajectory on both vehicles here. Stand by for the fairing separation.
Fairing separation confirmed.
Fairing is the aerodynamic shell that protects the Starlink satellites. The Starlink satellites are stacked like a deck of cards, and that shell basically protects it. But when the first stage is the second stage is high enough up out of the atmosphere where there's not enough air to really perturb the payloads on board, so they jettison the aerodynamic shell. Those fairings will actually end up falling back down, and they have a parachute on them, and SpaceX will get them back. The fairings don't need that much in the way of extra equipment to get them to come back down in one piece because they're so ridiculously light. Those fairings are carbon fiber and aluminum. They're very, very, very light. So dropping them from 120 kilometers up would be like letting a piece of paper go off a tall building. It'll sail back down. Very easy to get it. Just needs a little parachute at the end. Easy peasy. We're a little over 4 minutes into the flight. Second stage is 131 kilometers in altitude, traveling at 9,700 kilometers an hour and accelerating. First stage over here is going to reach its apogee here momentarily. If the way orbital mechanics works is if your altitude is going up, your speed is going down. If your altitude is going down, your speed will go up. So if you could see the speed, it's starting to accelerate, so we've gone past apogee here, meaning it's the highest point in its arc. So the first stage cut off, and it's just kind of coasting, and now it's going to fall back down. They inspect them, doubloon. Yep. Interesting. Scary.
Discovery, go at throttle up.
Hey, Guitars with the 5 subs. Thank you. So the first stage is just coasting. You can't really see it because it's dark.
Both vehicles continue to follow nominal trajectories.
But we're 5 minutes in here. Second stage is at 151 kilometers in altitude, traveling at 11,700 kilometers an hour. First stage is now accelerating pretty hard here, 105 kilometers and descending at 7,300 kilometers an hour. No problem, Guitars. Thanks for the 5-pack. I appreciate it. Okay, so the first stage, the cold gas thrusters, you might see some pulsing there on the left monitor. Those are cold gas nitrogen thrusters. It's basically a can of compressed air that's kind of pushing the vehicle and turning it so the engines are actually, it's flying business end first. You see right there that there's the chill down on the engines that they're about to start. See that little smoke coming from the middle of the screen? They're starting to thermally condition the engines again to get them ready to fire. The reason why the rocket wants to go business end towards the re-entry heating that's about to happen is so it can do this. Watch. Ready?
Stage 1, entry burn startup.
There you go. What the
Stage
Falcon...
1 FTS has saved.
This is the best part. What you're witnessing right there is called supersonic retropropulsion. Yes, that is the name of my metal band if I'm going to start one. What it's doing right there is actually using the engines to push re-entry heating away. That's why it's called an entry
Stage
burn.
1, entry burn shut down.
Now, it just bled off about 2,000
Stage 2
kilometers an
FTS
hour,
saved.
but the rocket engine exhaust is actually colder than the re-entry heating itself. So using it as a thermal column, a good thermal medium between your re-entry heating and the booster is what makes the booster come back. That's why it doesn't need like tiles or some crazy advanced thermal protection system. The engine exhaust is the thermal protection system. But that doesn't stop some re-entry heating from happening. You can look up on the grid fin there. Grid fins are hypersonic
Both
control
vehicles
surfaces.
continue to follow nominal trajectories.
Hypersonic control surfaces. They're there to make sure, to steer the vehicle in once it gets back down into the atmosphere, but it's designed to be able to steer it at like Mach 5. You need a different control surface when you're going that fast. That's why it looks like a waffle iron. So we're about 7 minute 25 into the flight. 158 kilometers in altitude on the second stage. 19,000.
Stage 1 is transonic.
19,700 for second straight trajectory. First stage is 7 kilometers off the deck going at 1,100 kilometers an hour. It should be subsonic right around now. Okay. We should see the startup here for the landing burn momentarily.
Stage 2, terminal guidance.
Stage 2 is in terminal guidance, indicating that onboard computers are using the acceleration of the second stage to determine...
Stage 1, landing burn startup.
To determine course. There's the landing burn on the first stage. 500 meters at 400 kilometers an hour. Should get a call here for landing leg deploy. There's an onboard shot from the landing ship.
Stage 1, landing legs deployed.
There it is. Oh, she tipped a little bit. Whoa!
Stage 1, landing confirmed.
Whoa, came in a little spicy there. But T plus 8 minute 35 seconds. Booster 1058 is back down on the drone ship. 18 freaking flights. SECO indicated second stage engine cutoff at 8 minutes 46 seconds. We should hear a call for nominal orbit insertion, indicating a pretty damn good and complete mission.
Nominal orbit insertion.
Easy. Pretty cool, huh? 18 flights for that booster. That doesn't suck. Show that landing again. I don't know if I can get a replay on this. The stage did this. It kind of like tilted at the last second. So that could have been two things. That could have been the stage actually freaking out, or it could be the drone ship in rough seas going up and down. Could be either one. Yeah, Vex, isn't that cool? It's 10 minutes. That's all it takes. Isn't that sick? And, dude, they do this every week. It's sometimes 2 times a week. It's on the frickin' daily, man. We launch rockets to space on the daily. Now, I love my civil engineering. I love playing cities. But, dude, this is like, oh, it's so cool. Let's see if we can, what do you think the limit for reuse will be, if any? Probably the tanks, if I had to guess. You say it's not rocket science, right? Yeah. SpaceX is making rocket science look easy, dude. All right, here we go. We got the replay. Let's go. So, yeah, let's look at that landing again real quick. The drone ship, you got some chop. There's some caps on the ocean. You can see it over there because the rocket's so damn bright, it's lighting up the water.
Stage 1, landing.
So watch. Deployed. Watch. Ready? Whoa! It came in kind of sideways. Whoa! Dude. Oh, dude, it started going sideways. You see that? And it tipped down right at the end.
Confirmed.
I think the drone ship may have been rocking back and forth. You remember what they said? If the drone ships are rocking, don't come a knocking. I think Elon said that. You can quote me on that. Yeah, I think they got hit with a large wave. I want high-res slow-mo of these landings. Yep. How does the U.S. protect SpaceX and NASA during these broadcasted flights? What do you mean, Sean? I mean, getting the telemetry of the vehicles, that's no big deal. As long there's certain parts of the rocket you don't want to show, but this is fine, easy peasy. And in terms of like intercepting it, SpaceX uses a pretty hardcore encryption. It's proprietary encryption, but SpaceX is pretty damn good about their cybersecurity because they don't want anybody being able to do this. They don't want anybody stealing their mojo. You know what I mean? Yeah, it's all encrypted, like hard encrypted. This is super hardcore cybersecurity, man. Oh, it's so killer. That's cool, man. 18 flights. That booster, and it's crazy. That booster's run 18 flights, right? Its first flight was in May of 2020. Not that long ago. I mean, that was pretty much in the before times, all right? But 18 flights in 3 years. You'd be hard-pressed to find any space hardware that gets to 18 flights, let alone in 3 years, right? Yeah, that's Booster 1058. Its first launch was DM2. The first launch of this booster launched people into space. Yeah, DM2 was its first launch. It's the worm logo booster. No, Smoke. SpaceX isn't worried about the chop. Recovery conditions are taken into account. The ocean around the drone ship is taken into account during the when they do the pre-launch forecast. They basically don't want to. I mean, like if there's a surprise tidal wave, I don't know. I'm sure they'll know about it and scrub the launch. It's, you can get a ping from the drone ship every 10 minutes and still, the sea ain't going to change in 10 minutes unless there's a big storm coming, in which case they would know that already, right? They look at the meteorological forecasting, like aeronautical meteorology is like super different than the weather guy going, I think it's going to rain here today. Maybe it'll rain here tomorrow. See, the difference is that those guys, the aeronautical meteorologists, actually have to get stuff correct. Meanwhile, the weatherman's like, it might snow, maybe, and then it's sunny and 80 degrees out. It might snow. Hey, buddy, that's some good shoes. It's like, all right. But yeah, they check the weather forecast. They also have trajectory optimization, Smoked. So if you notice, this was a southeast trajectory. So one of you guys had a question about flight azimuth. See, 54 degrees inclined. Because if you draw a line through the equator right here, we can denote orbital inclination from the tilt. So the equator's like right around here, right? If you made an angle where the orbital path and the equator cross, it makes 54 degrees. But this is a 54-degree incline launching on the descending node. This is the descending node trajectory, meaning you're going from the northern hemisphere to the southern hemisphere, indicating a southeast velocity, right? The other trajectory, Smoke, that they can do is they can launch up the coast and they can fly by my house. I actually can see Starlink launches when they go on the northern trajectory. The northern trajectory is the same thing, but you're going up, and that's called, they're technically both a descending node launch, but this one flies up here first and then comes back down. The tilt would be going in the opposite direction, but it's a similar type of orbit. What the difference here is, it would be, your longitude of ascending node. The ascending node, so basically where you go from southern to northern hemisphere correlative to longitude, helps denote where the orbit tilt is relative to Earth on the long axis. Inclination will tell us on latitude for the most part. What was the maximum amount of shuttle flights? So Discovery had 39 missions when it flew STS-133. 133 was its 39th. Yeah. Sewer Rat, I think I'm vested now. Too much of a VOD watcher. Well, thank you. I appreciate the support. And I'm glad you guys like the rocket launches. It's really cool. See last, please. Sure, Zim. Oh, it's buried, man. I'm sorry. There's a lot of people in here. Aren't they launching on this trajectory for improved recovery weather heading into winter? Correct. Yeah, that's right, Phil. That's why they're flying on the southern trajectory. They're flying on the longitude of ascending node on this one would be 180 out from the northern trajectory if you launched at the same time. It would be an orbit that's tilted it would be flipped around 180. Question, do you know if NASA ever grabbed that piece of... probably, Sawyer, yeah. The piece of the shuttle that came up? Yeah. So that beats the landing. Yeah, but keep in mind, so a little bit of perspective here. Discovery is probably the most reused piece of spaceflight hardware ever. 39 missions. But Discovery's first flight was in 1984. So from 1984 to 2011, Discovery flew 39 times. SpaceX Booster 1058, albeit being a first stage, so not flying technically, flying the same flight regime as Discovery, has been used 18 times in 3 years. So just some perspective there. Technically, if you wanted to compare apples to apples in this comparison, you'd compare SRB casings on the shuttle program. There were shuttle SRB casings that flew on STS-1, the first shuttle mission in 1981, that flew on Artemis 1, the mission that launched the uncrewed Orion capsule to the moon last year. There was a casing from STS-1 on there. Pretty cool though, huh? But it's 39 to 18, isn't it? Yeah. Yes, I thought we already established that, though. One of them is 39 over 27 years. The other one is 18 over 3. That's the point I'm trying to make, Steve. Does that make sense? Crazy, right? Spaceflight and stuff, dude. How many Starlink satellites are up there now? I've lost count, hashtag. It's in the thousands, easily into the thousands. Yeah, you gotcha? Right on, man. Yeah, Steve, Discovery's still the most reused one by a long shot. I mean, personally, I'm partial to the space shuttle. But, you know, if SpaceX is doing this with a partially reusable rocket, you know, when Starship, if Starship does what we think it's going to do, and it does what SpaceX wants to do, I'm pretty sure that 39 missions will get bested by a Starship. Oh, boy. I thought SpaceX was the highest. Yeah. Oh, you meant? Yeah, I got you, man. All good. Yeah, no. My baby, the shuttle, Steve, still holds that record. I don't think it's gonna be for long when Starship starts flying, though. I don't think it's gonna happen. But I've always said I will relinquish my love for the space shuttle when Starship does what the space shuttle did on STS-1, meaning, you know, the shuttle on STS-1 separated the boosters, they brought the boosters back, right? And then Columbia went all the way up, 2 days up there, came all the way back down and landed. All right? When Starship does that, I will consider shuttle vindication complete. Because, you know, I've been following space for a long time, right? I'm following space for a long time. I remember 10 years ago, 15 years ago, people saying reuse doesn't make sense. Reuse doesn't make sense. Nobody will ever reuse things. That reusing vehicles is stupid. The space shuttle shows that reuse doesn't make sense. God, I want to stick it to all those people so bad. Oh, please do that. Anyway, reuse doesn't make sense. Yeah, okay, guy. Hey, have you heard of the Minecraft mod called Create? I know about Create, Toasty, yeah. They're making a space add-on to Create? Oh, dear. When is the next Starship test? Mid-November. Second or third week of November. So, week to 2 weeks, Ghost One. From what I can tell. We're getting close. That launch license is coming. Will Starship land? So thought, please, on the first Starship flight? No, it's not going to. The first Starship flight will belly flop out into the Pacific Ocean somewhere near Hawaii. It's called the Pacific Testing Range. It's where the U.S. Department of Defense tests missiles. Pacific Test Range. And the first stage is going to land somewhere. The Super Heavy is going to land somewhere in the Gulf of Mexico. Actually, here, I can show you. I'll show you the trajectory. This is the ascent trajectory for the Starship IFT-1 mission. Now, in the future, they want to catch the sucker, which is just crazy. Still crazy to me. Like, in the future, they want to use the launch pad, this thing. See that? The booster's going to come down and land. The first stage will come down and land, and then these two catch arms, they can actually do this. First stage will come down and they'll catch the thing. They'll grab it right out of midair. And they want to grab the first stage in Starship doing that, which, yes, if that sounds as ridiculous as you think, yes, oh, it absolutely is. It's bananas. But that flight right there, those two, they're going to be expended. They really got to focus on ascent. They've got to worry about getting that thing up into space. So that's what they're going to do. Now, I don't know if you guys can get some scale from this thing, right? But look at the staircase on the launch pad. Should tell you how big this thing is. Starship's about 340 feet tall, so it's about 100 meters tall, 9 meter wide. So I don't know, about 30 feet wide, 330 feet tall. That tower right there is 150 meters tall, so it's about 500 feet. It is a monster of a vehicle. 30 feet wide. She's a beast, dude. Absolute monster. Hey, Ronaldus, thank you for that Prime sub, dude. How many stories? 33. And 33 engines. Targeting November 13th. What is Starship supposed to do? That's actually a super good question, hashtag. Fully reusable launch vehicle. So SpaceX's kind of stated goal is to reduce the cost per kilogram, the dollar amount per kilogram to get something up into space. 1 kilogram for the Americans here is 2.2 pounds, right? Right now, to get a kilogram of whatever, or about 2 pounds of anything, you get 2 pounds of styrofoam. To get that up into space is probably on the order of, like, I don't know, what do you think it is, guys? Like 18 grand, 19 grand to get a kilogram of something up into space? SpaceX wants to lower that amount. They want to lower that amount and basically make it like $100 per kilogram or something. And the only way to do that is to have a big honking launch vehicle that launches into space that's reusable so you can support a high flight rate. So, I mean, I guess it's trying to tackle the same exact problems that the 747 was trying to tackle in the 60s with airline travel. What I'm trying to tell you is that Starship is basically a 747 that flies into space. Yeah. Which, I mean, that's not easy to do. Yeah. Hashtag it's a monster. It's basically supposed to do what the space shuttle was intended to do. But it's a space shuttle that can move as much as a Saturn V into space. Got to reduce that dollars per kilogram to low Earth orbit. If you do that, so okay, another good way to look at it, dude, and you tell me if I'm going overboard with this. Another good way to look at it is that space flight right now, getting stuff into space, is a billionaire's game. Tres comas. It's a billionaire's game. Jeff Bezos, Elon Musk, Richard Branson. You know, multi-bajillion-dollar defense contractors. Boeing, Lockheed, Northrop Grumman. It's a billionaire's game, right? If they're able to Achieve a high flight rate. The argument can be made that it could become a millionaire's game. Well, guess what? There's a lot more millionaires out there than there are billionaires, right? If they make it a millionaire's game, dude, we're talking, you and I will be, in a couple of years, we'll be able to take a vacation to the moon. With plane, you buy Starship tickets like you buy plane tickets. If that happens, that's best case scenario. This kind of stuff has been tried before, so forgive me. I've been hurt in the past. This is the same kind of stuff that the shuttle promised, but here we are. IRL streaming on the moon would be quite nice. Yeah, there you go. $1 per kilogram. What's Falcon 9? Falcon 9 is $2,600 per kilogram. The space shuttle was $65,000 per kilogram. Okay. Right? Nuclear energy would be too cheap to meter. Exactly, Pontius. We gotta meter our expectations here. So I'm always looking forward to this, but I'm not gonna be ringing the victory bell until it does what it said it's going to do. But either way, we're all gonna be in for a treat when that thing goes. Should be sometime in the next couple of weeks. I mean, it is an absolute monster of a vehicle. That, like, once again, look at the ladder on the side here. That thing is huge. Couple of weeks. Yeah, it's gonna happen sooner rather than later, man. Anyway, let's jump back into cities, shall we?